Good evening, dear students. So we have the first module discussing about energy storage techniques. In that we have seen the pumped storage power plant as well as compressed air energy storage system. Now we shall see the next energy storage method, that is by means of batteries. So first one is the lithium ion batteries. Lithium-ion batteries are by far the most popular battery storage option today and control more than 90% of the global grid battery storage market. Compared to other battery options, lithium-ion batteries have high energy density and are light in their weight. Additionally, lithium-ion batteries are now frequently used in developing countries for rural electrification. In rural communities, lithium-ion batteries are paired with solar panels to allow households and businesses to use limited amounts of electricity to charge cell phones, run appliances, and light buildings, etc. Lithium-ion batteries has got a life of 1000 to 10,000 cycles and efficiency of around 85 to 95%. And the maximum power rating can be up to 100 megawatts capacity. So that's all regarding lithium-ion batteries. And next, storage device under batteries are lead-acid battery. Lead-acid batteries were among the first battery technologies used in energy storage. However, they are not popular for grid storage because of their low energy density and short cycle and calendar life. They were commonly used for electric cars but have recently been largely replaced with longer lasting lithium-ion batteries. Lead-acid battery has a lifespan of 6 to 40 years and an efficiency 80 to 90%. And the maximum power rating can be up to 100 megawatts. Next is flow batteries. Flow batteries are an alternative to lithium-ion batteries, while less popular than lithium-ion batteries. Flow batteries make up less than 5% of the battery market. Flow batteries have been used in multiple energy storage projects that require longer energy storage durations. Flow batteries have relatively low energy densities and have long life cycles, which makes them well suited for supplying continuous power. They have got a life of 12,000 to 14,000 cycles. Then efficiency around 60 to 85% and maximum power rating can be up to 100 megawatts. Now, hydrogen fuel cells. Hydrogen fuel cells, which generate electricity by combining hydrogen and oxygen, have appealing characteristics. They are reliable and quiet. They don't have any moving parts like conventional energy electricity production units. They have got high energy density and they don't release any emissions while generation of electricity takes place. The process can also be reversed, that is by making it useful for energy storage. Electrolysis of water by means of electricity can produce oxygen and hydrogen. That is, when electricity is in excess or low demand. When renewables are generating more than the demand, it has to be stored. Then this excess electricity is used for electrolysis of water in order to produce oxygen and hydrogen. This hydrogen can be stored for generating electricity. So fuel cell facilities can therefore produce hydrogen when electricity is cheap and later use that hydrogen to generate electricity when it is needed. In most cases, the hydrogen is produced in one location and used in another location. So hydrogen is portable, can be compressed in storage equipment and can be transported to anywhere where electricity is being required. Hydrogen can also be produced by reforming biogas, ethanol or hydrocarbons, a cheaper method that emits carbon dioxide and causes pollution. Though hydrogen fuel cells remain expensive primarily because of their need for platinum, an expensive metal, they are being used as a primary and backup power for many critical facilities like telecom relays, data centers, credit card processing, etc. So when electricity has to be generated, hydrogen is allowed to, the stored hydrogen is allowed to combine with oxygen from air and water will be the byproduct producing electricity. Lifespan is around 5 to 30 years and efficiency 25 to 45% and maximum rating 100 megawatts. Next is the flywheels, energy storage by means of flywheels. Flywheels are not suitable for long-term energy storage but are very effective for load leveling and load shifting applications. Short duration load changes, these flywheels can act as an energy storage. When there is a fall in the load, energy can be stored in flywheels, and whenever there is a sudden increase in demand, energy stored in the flywheels can be used. So, these flywheels can be used as a storage device for instant applications. Flywheels are known for their long life cycle, high energy density, low maintenance cost, and quick response speeds. Motors store energy into flywheels by accelerating their spins to very high rates, that is up to 50,000 RPM. Okay, an electric motor will be coupled with flywheels. So whenever there is electricity in excess, the motors are operated and this energy is stored in terms of mechanical energy on flywheels. So whenever the electricity is in demand, from the flywheels, we can retain the mechanical energy and supply it to the motor. Motor in turn acts as a generator when mechanical power is input to that device. So electricity will be generated in the reverse direction. The motor can later use that stored kinetic energy to generate electricity by going into reverse. Flywheels are commonly left in a vacuum so as to minimize air friction, which would slow the wheel. This is the diagram. We are having a motor here and a shaft connecting the hub and a rim. Then all these are enclosed in a vacuum chamber. Whenever electricity is in excess, the motor will be supplied by that energy and the motor will be producing mechanical energy and the shaft will be conveying this mechanical energy to the rim. Rim will be accelerated and mechanical energy will be stored in it, and whenever there is a demand for electricity, mechanical energy stored by this rim will be supplied to the motor by means of the shaft. Whenever mechanical power is input to this machine, it will act as a generator and generates electricity when it is required. A flywheel is a rotating mechanical device that is used to store rotational energy that can be called up instantaneously. At the most basic level, a flywheel contains a spinning mass in its center. that is driven by a motor. And when energy is needed, the spinning force drives a device similar to a turbine to produce electricity, slowing the rate of rotation. A flywheel is recharged by using the motor to increase its rotational speed once again. The life is around 20,000 to 100,000 cycles. Then 70 to 95% efficiency, and the maximum power rating can be up to 20 megawatts. So we have discussed various techniques for energy storage, and energy storage is a must when we are using renewable energy sources, because renewable energy sources are unpredictable. Mostly in the case of solar energy, wind energy, etc., we cannot predict the availability of input, that is solar energy and wind energy. So we cannot predict the output also. So whenever the input is available, we can generate electricity. But at that time, electricity may not be in demand. So we have to store that. So storage is a must along with non-renewable energy sources. So with this, we finish the energy storage system as well as the first module of non-renewable energy sources. And the next session, we shall start with the second module. Thank you.